Hi, I'd like to go through some of the basic points of atomic physics with you from the Cambridge CIE iGCSE physics course. The 2 points that I'm going to be going through today are this one, the atomic model and the basic core content describing the structure of an atom, and then looking at how scattering of alpha particles provided evidence for the nuclear model. So the basic points in terms of the atomic model as we see it now are that you have a nucleus, the center of an atom, that is positive, and then there are electrons orbiting that are negative. Now these negative electrons are attracted to the positive nucleus, and that's what keeps them in their position. The nucleus is made up of protons and neutrons, neutrons being neutral, protons being positive, and the neutrons help to space the protons out just a little bit because obviously the protons are repelling each other. The next specification point looks at the evidence for this. So this experiment is known as Rutherford Scattering, and Rutherford had this idea about scattering alpha particles, which are helium nuclei, which are positive at thin gold foil. Okay, and what he was hoping to do then was to see from what happened to them that would be caused by the structure of the nucleus or the structure of the atom. So he wanted to try and find out what the structure of the atom was, basically. So what I've got here is I've got 1, 2, 3, 4 different alpha particles being fired at this gold foil. Now this gold foil, okay, is made up of atoms, and it's these 3 atoms that I've drawn here. Now in reality there's more than 3 atoms, but the whole idea of the gold foil is the gold foil was very, very thin because gold is very, very malleable, so you can beat it down into very thin shapes. So that meant that you didn't have many atoms thick, so you were hopefully only looking at single atom interactions. Now when they fired the alpha particles at the atoms, the majority passed through undeflected. Some of the alpha particles that were deflected by small angles, and that could have been caused by a positive or a negative charge, which would have affected the path of the alpha particles. But there were also some large angle deflections, okay, which would have been caused by extremely large repulsions and some interactions like this where the alpha particles were fired straight backwards. Now those had to have been caused by the repulsion of a positive particle here coming towards the positive nucleus here. So that positive particle, that's the alpha particle, fired straight backwards. So what that gives you then, here is a brief summary of the experiment. Now you can read it yourself. Basically, some particles were repelled at large angles, and that deduced that there was a positive nucleus. Only a small number of the particles were scattered at those large angles, or straight backwards, and most of them were undeflected. So that shows that the atom is comprised largely of empty space. Had there have been more nuclei, or a higher density of nuclei, more would have been deflected backwards at large angles. And these findings led to what we call the Rutherford Model now. Rutherford was the scientist, and that's the basis of our current atomic model, where there's a small central nucleus that's positive and the electrons orbit the nucleus. Okay? Now if you go back to the start, these were the specification points that I wanted to look at, and hopefully you should be okay with the core and the supplement. Okay, we've got scattering of alpha particles for a thin metal foil provides evidence for the nuclear atom. That's what we just covered, and at the start of the mini lesson we had the structure of the atom in terms of positive nucleus and negative electrons. I hope this has helped.